So they want us to discuss the existence of this limit. So let's think about what is always the idea with limits. Always the idea with limits is you're plugging in numbers that are closer and closer to zero. So let's just go straight to Desmos to do this, to be honest. We don't need to try to do any math for ourselves. We'll do f of x equals, here, let's turn off the graph. We don't need to cheat and try to look at the graph and get it from the graph right away. We'll look at the graph at the end. So f of x equals 1 over x squared. And we're going to do just like we did before. We're going to say what happens if we plug in values really, really close to where they want 0. Really, really close to 0. So like 0.0. See, if we plug in 0, it's undefined. That's the whole problem. But if we plug in 0.001, we get 1,000,000. Now let's see, does that get closer to a specific number as we add more zeros? No, it does not. It gets bigger. So it's going up to infinity. So it's pretty valid to say the limit as x approaches 0. Let's see, this is positive, so this is from the right side. So that's like infinity. Another way to say, though, when a limit equals infinity is to say that it does not exist. From now on, whenever I want to say does not exist, I'm going to write D and E. And you can say it does not exist because infinity is not a number. It just does not approach a specific number. Yes, it gets bigger and bigger, but with a limit, you want to say that it gets closer and closer to a specific number. And that's not what's happening here as x gets closer and closer to 0 from the right side. And actually, you can see that nothing happens when we include the negative. It's still just positive. So the limit as x approaches 0 from the left side is also infinity. So even from the very beginning, we could have said that this limit does not exist because it equals infinity. But I really think it is useful and in a way is valid to say that the limit as x approaches 0 of this function is infinity. And it's like you can't say it's equal to infinity because infinity is not a number. Something can't be equal to infinity. So I guess you say it approaches infinity. And that's what we see, that the more zeros we add here, the closer and closer we get to 0, just the bigger that gets. Which makes sense, especially when we look at the graph. Because here's the graph, and you see as we get closer and closer to 0, both sides of the graph go up. They're both going to infinity. And now that's going to be a little different if we change the equation to make this exponent like an odd number, because then they're going to go different directions. Now one's going to positive infinity, the other one's going to negative infinity. So here we definitely cannot say the limit does not, we definitely should say that the limit does not exist because they're going in opposite directions. But if it's an even number, then in a way I think we can say the limit does exist because they're both going in the same direction.